So we are going to look at rational exponents. Remember that the word rational means fractions. So what we're going to be doing now are fractional exponents. For example, how shall I do this? Okay, let's take actual numbers. 9 to the 1/2. 9 to the 1/2 will mean the square root of 9. In other words, this 2 will go in what's called the index of this radical sign, and that's all it means. On the other hand, 8 to the 1/3 will mean the third root of 8. So if you get a problem like 9 to the 1/2, you don't have to change it to this. You could simply say that this is equal to 3. The square root of 9 is equal to 3. It's just another way of writing the square root of 9. And when you write the square root of 9, you don't really need this 2, as you know. This 2 does not have to be there. 8 to the 1/3 will equal 2. Yeah, because the square root of 9 is 3, so 3 times 3 is 9. 2 times 2 times 2 is 8. Okay, that's the first part of this. Then we look at something like this. And this will mean the bottom number, as you know, is the index. So that would be the third root of 27. And then you have a 2 over there, and that will be equal to that. So the bottom number puts it in a radical, and the top number simply raises it to an exponent. So the answer here will be the number which, when multiplied by itself 3 times, will give you 27, and that number is 3, and then to the second, and the answer would be 9. So this 3 goes there, this 2 goes there. And you always do the square root, the root first. Let me repeat that. You always do the bottom number, which is the root of that first, and then you raise it to the exponent. 16 to the 3/2. Now this will be equal to, so let's first do the radical. So the square root of 16 raised to the third power. Remember, this is the second root. So it's the square root of 16, which is 4, raised to the third power, which equals 4 times 4 times 4 times 4. Yeah. Which will equal, of course, 16 times 4, or 64. Okay, get me idea there? How about a negative? How about, so this is problem 1, this is problem 2, this is problem 3, This is problem 4, problem 5, and problem 6. Okay, now problem 7 will be,
Professor,
yes.
just to be clear, you didn't put a 2 with the square root 16 because square
No,
root is 2. Correct?
yes, it's assumed to be. It's like writing an X to the first. You don't really have to do that, so you just make an X. The square root of 16, you don't really do that. You just put the square root of 16. There are some things you just don't put, okay? Um, Negative 144 to the 1/2. And number 8, all right, so let's do number 8 first. So the square root of negative 144 doesn't exist, right? There's no answer. There's no answer using rational, real numbers. So this doesn't work. This one does work because this means take the negative and put it on the side and do the square root of 144 first and get 12 and then put the negative. See, there's an answer to this one. There's no answer to this one. Get it? You can't take the square root of a negative number. No number times itself will give you a negative number. I mean, we could, if we wanted to, we could say, all right, well, the square root of negative 144 is the square root of negative 1 times the square root of 144. And this is I, and this is 12. So the answer is 12I. You could do that, right? Just by, I mean, this is an imaginary number, but we haven't been talking about imaginary numbers. We're talking about real numbers. And this would give you the real number. This would give you the imaginary number. And actually, this problem as well. These are our last two problems from this section. We're sort of running out of time, so I have to kind of move ahead. This is equal to 9 to the 1/2 times z to the 6th to the 1/2. This is the square root of 9, which equals 3, right? And this one is z to the 6 times 1/2. 1/2 of 6 is 3. And that's the answer to the question. So first, you change this to this times that. The square root of 9 is 3, and 1/2 of 6, 1/2 of 6 is 3. And that's the answer to the question. Okay, nobody's saying anything, so we move on. Again, this is 125 to the, well, actually, you know something? Here's how I do the problem. I would recognize this negative exponent I would recognize that negative exponent and immediately make the problem 125 x to the 12th to the negative 1/3. Excuse me, to the positive 1/3. Okay, in other words, I took the negative and used it to make this into a fraction. And then this becomes 1 over 125, the third root. Well, let's do it separately. Let's do 1 over 125 to the 1/3 and x to the 12th to the 1/3. So the first thing we did was make the exponent into a fraction. The negative exponent became a fraction. Then we did the 1/3 to the 125 and the 1/3 to the 12. And now we work it out and we get one over the third root is the same thing as the third root of 125 and one.
Professor, could you move down the camera, please?
Oh yeah. And then 1/3 of 12 is x to the 4th. Now this becomes 1 over 5x to the 4th. This is the answer to the question. So we now look at section 3.3, which is simplifying radicals. I think in the book it's actually called simplified form of radicals. Which is the same exact thing as what I said, except it's just written differently. Okay, now this is what it means. Problem number 1. The square root of 9n to the 4th. Okay, write down what you think the answer is. This is the same thing as the square root of 9, which is 3, and the square root of n to the 4th, which is n to the 2nd. Right? Any questions? Number 2. The square root of 16n to the 8th. Write down what you think the answer is. Okay, that's all you need. The square root of 16 is 4, and this is n to the 4th power. Remember, when you take n to the 4th and multiply it, so the reason is that n to the 4th times n to the 4th is not equal to n to the 16. Remember that. It's equal to n to the 8th. Because when we have two terms being multiplied, we don't multiply the exponents, we add the exponents. So when you're taking the square root of something like n to the 8th, you actually take half of the 8. Half of the 8 is 4, such as the square root of n to the 10th. What would that be? N to the fifth. Again, you're taking half of 10 is 5. N to the 12th will be equal to n to the 6th. Get it?
Yes.
So we're okay when the exponent is an even number. When the exponent is an even number, all you do is take half of the exponent. Let's write that. When you take the square root of a base to an even number, take 1/2 of the exponent. And that's what we've been doing. We've been taking half of 10 is 5. Half of 12 is 6. However, when you do a problem like x to the 9th, the third root of x to the 9th, can that be done? Then you're not taking half of the exponent. You see this, remember what we did in the previous chapter? We did this. This was the same thing as this. So when it's a divisible by 3, then it becomes 1/3 of 9, which is equal to x to the 3rd. The fourth root of x to the 20th is the same thing as x to the 20th to the 1/4. So you could, when you take the third root of a base to an exponent that's a multiple of 3, then you take 1/3 of that. When it's to a, 1/4, you take 1/4 of 20. So whatever the exponent happened to be, you take that fraction of the exponent. Now, the problem becomes, what do you do in this situation? The square root of 9n to the 4th, to the 5th, excuse me, the square root of 9n to the 5th. Well, you separate this into 2 parts, the square root of 9, the square root of n to the 5th. Well, this is easy. This is easy because this just becomes a 3, but this is a problem. There is no such thing as the square root of n to the 5th. So you separate this into an even number and then just whatever is left over. And this becomes 3n to the 2nd times the square root of n. The square root of 18, a to the 5th, b to the 4th. Remember what we've been doing when we were doing especially imaginary numbers? It's going to be separated into 2 parts. 18 would be 9 and 2. This is all square roots now. Forget about third roots and fourth roots. The square root of 18. Take out the perfect square. Take out the perfect square. Take out the perfect square. See what I did? I separated this into the 18 became the perfect square times the number. This became the square root times whatever was left, which was 2a to the first, if you will. And then b to the fourth is a perfect square. And this becomes 3a squared b squared times the square root of 2a. Next problem. The square root of 25 m to the 13th n to the 9th. The perfect square is 25. M to the 12th. And then M to the 1st. N to the 8th. And M and N. See how we did that? We took out the perfect square. That was easy because that was just 25. But this is not a perfect square because it's an odd number. So we took out the even number that was closest to 13 and then just put whatever was left. N to the 9th. We took out n to the 8th and then put the n over there. And this became 5m to the, you take half of it. So it's half of 12 is 6, half of 8 is 4, and that you just leave into the radical, just like that.
Wait, Professor?
You need to study these things. Between now and Thursday, you need to study these and do the homework. Yes, question.
Yes, what I did was I took out, I split m to the 13 into m to the 9th and m to the 4th.
No, you didn't go far enough.
No, I mean, I was not, so I got m to the 3rd and m to the 2nd.
No.
So that was not actually,
No.
okay.
The square, in other words, what you said was the square root of m to the 9th is m to the 3rd. Right?
Yes.
No good. Because we were told right here that when you take the square root of a base to an even number, take 1/2 of the exponent. So you have it's
So it'll be,
not, yeah,
okay.
it's not, in other words, if this were the square root of 9m to, I don't know, the 8th, then it would be 3m to the 4th. You take half of the number. So this m to the 9th,
Oh, okay.
this m to the 9th would be really equal to
4.5.
No, don't. You don't want to get into fractions and decimals. This is what it's equal to. It's equal to m to the 8th, and just leave that alone over there. Like m to the 4th, half of 8 is 4. Get it?
Yes, I do. Okay.
Here's another problem. We're running out of time, so we've got to kind of move quickly now. I want to do two more problems. This is the next one. 32 a to the 7th, b to the 10th, c to the 3rd. So let's see if you could do that. I'll give you a couple of minutes, but then we really have to move. See what I did? 32 is not a perfect square. The perfect square is 16. So 16 times 2. Separate them. A to the 7th is not a perfect square because you can't divide 7 by 2. Exponents are different from regular numbers. Regular numbers, you take the square root by just taking the square root. Like the square root of 16 is 4. But when it comes to exponents, it's 1/2 of that exponent. So it has to be an even number. The closest even number to 7 is 6. And that would leave you with a to the 1st. B to the 10th is a perfect square. Take it out. C to the 3rd would have c to the 2nd times c to the 1st. And this would become 4a to the 3rd, taking half of everything. Half of 6 is 3. Half of 10 is 5. Half of c to the 2nd is c to the 1st times 2ac. And you don't need just one. This is the answer. One last problem. One last problem. The square root of 50 x to the 13, y to the 15, z to the 12. Do that one. So we're separating this into two parts. 25 times 2. X to the 12th times x. Y to the 14th times y. And z to the 12th is already a perfect square. Let me move this over. This is too close. Everything is becoming crowded here. Z to the 12th. So, and this would be 2xy. All right, so if you wanted to check it, 25 times 2 is 50. 12 plus 1 is 13. 14 plus 1 is 15. And z to the 12th. And this becomes 5x to the, now you take half of these, x to the 6th, y to the 7th, z to the 6th, times the square root of 2xy. This is it. Here's the problem. The third root, not the square root, but the third root of 8 a to the 3rd, b to the 7th. We're not talking about perfect squares now. We're talking about perfect cubes. Perfect cubes. Here's what it is. So this will be all cube roots. 8 is a perfect cube. A to the 3rd is a perfect cube, but of course b to the 7th is not a perfect cube, but b to the 6th is a perfect cube. Because you could take 1/3 of 6. You could take 1/3 of 3. And what do you do with the extra 1 left over? You put it in here. We don't need such a big one. Now you get 2a b to the second times the cube root of b. And that's the answer to the question.